Okay, hey, this is Jeff Pulver. Sarah, I met you last year at the conference, and we were talking about deployments that were relatively similar to Maine around the country that you had experience with. Was it Grand Rapids that was kind of the small city in a relatively rural northern climate? Is that the best example that you would provide for that would be comparable to a Maine city?
Yeah, absolutely. So Grand Rapids, Minnesota is a population of only about 11,000. It is fairly geographically spread out. And so we have a pretty large service area there. We have, I want to say we're up to about 87 pickup and drop off points within that geographic area that are all kind of determined through community input. And again, fairly rural. We've had to be very creative. We actually worked with a local group of youngsters, high school students, that were working on some cool science type and autonomous type programs. And there's one area of roadway where there's nothing on the sides of the roadway. So for our sensors didn't have the ability to pick up some of the perception because there was nothing for those sensors to kind of bounce their signal off of. And through working with this group of youngsters, we gave them some parameters on what were needed, and they actually created these pylons that were really cool pylons, decorated up very very neatly based on some city things that the city was proud of and things like that. And those were placed along those roadways to help with that perception. And now we operate autonomously in that area. We also have experienced some roadways that weren't exactly perfectly paved. So we've done some learning on that. And roundabouts were another one. They have a lot of roundabouts there, which is actually a little bit unusual for some of these rural communities. But that was another one, some train tracks, things like that. Um, the majority of our program there is run in an autonomous fashion, meaning the operator in the vehicle does not have to take over operations. But there are still a couple of areas that, they would have to operate that unless we utilized a different roadway.
Okay, great. That's really helpful. And we have about 5 people here from MaineDOT today that are in either traffic engineering or mobility analysis and engineering, or kind of at the front of our, automated vehicle rules and discussions about what pilots might look like and things like that. So one question I had is, it sounds like every situation is different in many ways, but what role does the state DOT staff generally play when a pilot comes in, besides just setting the rules? Are they often in meetings with municipalities, a liaison? Are they generally hands-off? Can you speak to how that has worked in several examples across the state, across the country?
Yeah, absolutely. And you're right, it is different in every location. I would say, for example, and please know that I don't mean this positively or negatively for any of these states, but in California, for example, we don't get a lot of participation from the DOT there. It is mostly local focused from the state, county level. And they handle all of those kind of on their own. The state, of course, sets the policy. We follow the policy, but they're pretty hands off. Places like Michigan, places like Minnesota, the state DOT is very, very involved. They have been involved from the beginning. They're huge advocates for the programs. They have some pretty hefty initiatives of what they want to see within their state in the coming, 10 to 15 years. And they're very active in playing a big part of that. They help us to find and identify areas where this type of service may work best. They've gone through a lot of workshops with us to learn as much as they can so that they are very aware of where the best places might be. And they help to even bring opportunities to us. They also have helped with funding. So whether that's their own funding or identifying federal funding that they could then participate in applying for. So it is very different across, every state. But I think the ones that are the most successful have been the ones that have been more hands-on.
Great. Don't be shy. Come on up. This is your chance. I have a question for Rick. I wonder if you can describe a little bit more about some of the human machine interface projects you have going on and some of your successes and upcoming challenges you're facing.
Oh, man. Let's see, what do we got? We're studying, mostly we're just studying the way in which all humans are interacting within a vehicle. Like, I mean, if you think of this in terms of you guys like fighting with your AI system to get information. Well, the same thing can happen when there is no other human in the vehicle. So like, what do you do if you have people with accessibility needs in the vehicle? What do you do if you have people with cognitive needs? There's also a lot of discussion amongst the car companies. Have not heard it from May, but about putting like kids, like, 8 and older in these vehicles. These are all interface issues that need to be dealt with. And just in case people are thinking, well, these are engineering things. Most of the car companies no longer identify themselves as car companies. They're not car manufacturers. They're now technology companies. I know Ford's recently changed it and everyone else is. So they've moved, I've said this before, they've moved from this idea of creating tools that we use and moving to the idea they're a service organization like a hotel or, resort type thing. So how do you make the ride efficient, comfortable? It's, as Sarah was talking about, once you ride more in it and you get that level of comfort and understanding to move forward. Some of the challenges we have coming up is like the things we don't foresee. And it's always the weird stuff that shows up, it could be from anyone from like somebody gets in with their hair on fire to some cocaine driven pet that's in your car. I have no idea. I'm making this stuff up right here on the fly. But these are the type of stuff that we need to start to address. You don't have cocaine pets in your cars, Sarah? What's going on? But these are the type of things that we're going to need to, start to look at moving forward. And this is that level of human interface that we're looking at. And as I will say this because I just said it to my staff this morning, the communication that comes from the AI systems to the human is important. But we're focusing on that in-between collaborative communication between the two. What does it need? What do we need? And that's where we come from. Hopefully that answers your question. Oh, Rebecca, we get a good Rebecca question coming up.
Thank you. It's a great presentation session. So I have 2 questions. So speaking about the legislation changes, so maybe it's really hard to kind of deploy on the streets for transporting people. But do we have any kind of initiative just starting maybe for truck driving, autonomous truck driving in Maine? And the second one is so some of the universities, they may have this kind of test bed, an outdoor setting, but not within lab, right? So they have test track. So I'm thinking whether we can have a University of Maine, maybe. So as a kind of bridging the gap between the 46% of no, I don't trust the AV to the 90% about I want to give it a try. So maybe that's kind of bridge will help us to build the trust on the way and maybe for future deployment on the public right away, maybe. So just want to gather more information and your thoughts on this kind of issue.
Well, first of all, operating at a university not on private roads is easier because of the regulatory is different as opposed to public roads. So we could do that with much less, much easier. I think the challenge for all of us who want to promote this technology is to find the use case to get this, to demonstrate it. I mean, Sarah and I and Rick, we've written grants together. We just have not gotten successful yet to find the application to make this happen. And I throw this out to anybody here, which is to come talk to us, and we'd love to try to deploy something in the state, any of our TIDC states. Let's do this. I know Rhode Island has a vehicle that they test at the university, but I think it's important. We kill 40,000 people a year on our roads. They should go down, right? It's a lot of people. We can reduce that. There's safety here.
So this is kind of a broad question, so maybe any one of you could respond. But can you say something about what you feel like are let's say the next steps that are necessary or the roadblocks to getting to scalable level 4 and ultimately level 5?
Sarah, I'm going to throw this one to you, Sarah.
Yeah,
'Cause you-
yeah, absolutely. So, you know, right now I can speak for what we are doing at May. I can't necessarily speak for other companies, but right now we are doing a lot of work that is towards increasing the capabilities, increasing the ability to scale, and looking really down the road at commercialization. As this year started, it was a little bit of a challenge for us because with the new administration coming in, a lot of the grant programs that were out there that funded our programs had been delayed a little bit, and there was some questions in the air on what that delay would be, how long it might take. And so as a company, we really had to look internally and say, okay, what are we going to do in the meantime if we're not putting cars on the road through these new programs and new grant availabilities? What are we going to do in the meantime? And so this year we actually partnered with both Lyft and Uber for a couple of different reasons to, access another market of transportation, but also to expand the capabilities of our autonomous technology. Looking at programs where in the past we have said, okay, you have to have a set number of pickup and drop off locations, to working with a team like a Lyft and an Uber where they can pick up from anywhere, really challenges our technology. And so just, as we continue to look at scalability and look at growth, we're looking at these opportunities on where we can improve what is currently existing and take that technology to the next level. It's a challenge, of course, as with anything, but it is something that we are looking to be able to scale pretty quickly over the next 2 to 3 years, going from a fleet where we have maybe 50 vehicles on the road throughout our different deployments to a level where we have 300 and 400 vehicles in 2 years, and then up to 1,000 vehicles after that, in the following year. So pretty quick scalability, but the technology has to get to that point first. And in order to do that, we have to be able to utilize our services in different areas and face some of these different challenges so that we can learn from them.
This is a question kind of specifically for Luke. In your map, I noticed a lot of the connected vehicle locations were across the 95 corridor. And what would be how would we expand that into more rural areas? And do you see a use case for that?
The map was kind of misleading to begin with, but you are right. The connected vehicle pieces we put out now are in the more metropolitan areas. It's actually more Augusta, Waterville than over the whole map. Spreading it to the rural areas does bring its own difficulty, which is something I believe is going to be addressed anyway, because the current thought about connected vehicles is you need a roadside unit. Now, these things only have a range of a mile under their best conditions. We obviously can't blanket the state in those. There are areas of the state which don't have power next to our roads, or we don't have a good communication line. So the chances are we're going to be looking more at the CV2X, the cellular to everything connected vehicle, and they're going to be getting a direct, at which point anything we get just covers the state automatically. As long as you've got a cell signal, you'll get the information to your vehicle. That then brings it, how it's going to be localized to getting the right information to the vehicle, brings it to what the central control software can do, how it's geo-fenced, how that area is defined in that software, and then vehicles entering that boundary will automatically get it. And I'm sure I can, is there any further expansion on that?
No, that covered most of it. What would be kind of the best uses for this technology in rural areas, do you think?
I think we have a number of situations which are unique to different areas. One of the ones we're trying to address at the moment with current technologies is up north in a lot of the field areas during the winter, we get a lot of blowing snow. So a plow truck can go through an area, clear it off. In about 5-10 minutes later, the snow has actually blown a decent sized drift back over that road. So having the technology to tell the drivers before they turn, or before they pass the last turn off, that that road is going to be blocked. There's going to be snow. Other sections down by the coast, we have areas where in extreme high tides, that section of road is going to flood. Again, the problem is currently being dealt with by building a slightly higher road in that area to get past that situation. But having remote technology where we can inform the driver beforehand, it will help.
Thank you.
Or any, okay, we got one more, yay.
Looks like we're up against the clock, but last one, and I think for Luke, and I know Sarah spoke to it a bit, but just security, cybersecurity, as we get more and more connected on these vehicles and the communications, both vehicle to vehicle, vehicle to infrastructure, and then obviously with our autonomous vehicles.
I'm not going to lie, I'm not a cybersecurity expert. I know it's a problem that when connected vehicles come up is being addressed at a quite high level. It will be a lot of security certificates, like your HTTPS websites if anyone's into that kind of thing, have a particular certificate which tells you that site's safe. So a connected vehicle will have a certificate attached with it, generated by a central unit to say that is a vehicle. And again, anything talking with it will need their own certificate, and it will be through the handshakes. But again, I am not a cybersecurity expert. I'm afraid I can't get a whole lot of details on that. It's beyond where my knowledge is. I don't know if Sarah's got any better answers on that one.
I, like you, Luke, I'm also not a cybersecurity expert. What I will say is that we do have a whole team that works on the cybersecurity side of things. They've taken a lot of measures to specifically address that. It is one of the reasons why we don't remotely operate that vehicle. I know one of the other things, and I don't want to, misspeak about how it's done, because I'm technology, even though I work for the technology company, is not the technology side is not my expertise. But I know that there are certain ways that our information is stored and protected that have multiple redundancies to be able to alleviate a lot of those cybersecurity risks. And it's something that they are looking at on a consistent basis to ensure that everything is as safe as possible.
Great, thank you. I think we're gonna have to call it there because it's up against lunch. And so we have during lunch coming up, we have the Dean of the Maine College of Engineering and Computing, Dr. Giovanna Gui, I'm going to kill her last name because I'm not Italian, Guidoboni. Is that right, Rick? Thank you. And we'll return at 1:15. So let's thank everybody.